Hi all, this is Celso Batalha, Evergreen Valley College, and let's go to briefly review the slides of Chapter 2. So basically, Chapter 2 is an introduction to what we see in the sky. So there are two types of motions that we are subjected to, and those are the motions we experience the most, and we are pretty much aware of them. One um, is Earth rotation. Earth rotation gives rise to day and night, and the other one is Earth revolution around the sun that gives also um, the sense of us seeing different constellations throughout the year and experience different seasons. And so those are the two major ones. There is also precession, and I will mention these probably in the chat room with some examples. Chapter 2 also, as Earth rotates, we also experience different um, constellations in different sky positions on an hourly basis. So Earth has a rotation that averages out 24 hours a day, and as Earth rotates, we see constellations slowly drifting from east to west as a result of this rotation. So chapter 2 is what we perceive out there in the night sky and what are the sources of changes we perceive. You don't need telescopes to kind of follow subject of chapter 2. Um, just as a reference, if you are following this, I would recommend you to download this free of charge software. Oops, not. Wait a second. Stellarium.org. Um, so you choose whatever system you have, a Macintosh or Windows, and download is a planetarium that can allow you to see night sky. I will be using a planetarium software in the chat room, and it's called Starry Night, but is not free of charge. Stellarium is an open source, is very good, is really good. You can see the night sky from any particular position on Earth. You can go north, south, Australia, it doesn't matter. Any time of the day, you can go back to the moment you were born and see what the sky looked like if you like this type of things. Um, so back there. And also, the most conspicuous object in the sky besides the sun is the moon. And we all know the moon goes through phases. And also, we are a few days from total solar eclipse. I know when you're following this video, the total solar eclipse has passed. So I'm kind of in the past here talking to you. But so we are going also to explain, to go through eclipses and moon's phase in this chapter. So Earth rotates. So if you are looking from the North Celestial Pole down on the solar system, Earth goes around the sun in a counterclockwise direction. And that's what this figure is indicating. You are pretty much in the North Celestial Pole or North Pole looking down on Earth. So Earth goes in a counterclockwise motion around the sun. And if you observe the moon is to the right of Earth and a little bit above. Moon also goes around Earth in a counterclockwise direction. But not only that, if you look at the arrows, the curved arrows around Earth and Moon, indicating the direction of Earth rotation, you realize that this direction is also consistent with the orbital direction of both Moon and Earth. in fact, later on in chapter 5, we are going to see this is the result of the Earth, the way the solar system as a whole was formed, a system that consists of a central sun or protosun surrounded by a circumstellar disk, and this disk, consisting of gas and dust, was orbiting the sun in this counterclockwise direction, and out of which the planets we have and satellites, most of the satellites uh, got crystallized, and then they inherit this motion. So first subject is the so-called celestial sphere. Celestial sphere does not exist. But if you are lost in the woods and completely dark, no moon in the sky, and you look up to the heavens, you have the impression that you are surrounded by a dark dome where the stars are. So it was not difficult for ancient astronomers to create this hypothetical sphere. We still talk about celestial sphere, but again, it really does not exist. Stars are not in it, any star, and if they were, they would be at the same distance from us, Earth, which in this picture happen to be in the very center. So celestial sphere does not exist. We saw in chapter 1 that our solar system is part of a galaxy of hundreds of billions of stars, and galaxy, our Milky Way, is not a sphere, right? So sphere is, again, does not exist. But it was easier in those days to believe that way, because that what appears to be the case, but it was wrong. As being centralized, as being honored, and as slowly observed the drift of stars and planets from the eastern horizon to the western horizon, it was not difficult to conceive that planets and stars were kind of glued to a celestial sphere that happened to be orbiting Earth from east to west. So nowadays we know this is not the case. Earth itself is, as it was shown here, Earth is a globe that happened to be rotating the space, and being on Earth, this rotation is from western sky to the eastern sky. And as Earth rotates, it slowly rotates, and taking an average 24 hours to complete one turn from west to east, we see these stars and we see planets slowly drifting the other way from east to west. And in this picture, you see indicated the so-called celestial points: North Celestial Pole, South Celestial Pole, Celestial Equator. So what exactly they are? Now, if you go back here, see this North Pole that happen to be in the middle of this white spot representing pretty much ice. So there is a southern pole, which we don't see, is in the far side of this figure. So if you take these two poles and connect them by a line and extend it towards you, that's happen to be observing this, so it would hit probably the middle of your eyes, and that would be the North Celestial Pole. See that? So you take the North South Pole, connect to a line, and extend that to infinity, and that would indicate a point in the sky that is the so-called North Celestial Pole and Southern Celestial Pole. Now, by the same token, if you take Earth equator, and extend that out to infinity, you would create and define what is the so-called celestial equator. Now, the Sun does not orbit Earth. Earth orbits the Sun, as it's well shown in this figure, right? But if we observe the Sun throughout the night sky, let me see if I can bring the software here, the Starry Night. There you go. and I will use more of my chatting time to explore this software here. So if you allow the time to go faster, see the sun is slowly migrating from east to west, the time is ticking quickly, and I will increase this time. There you go. Now it's going fast, and eventually the sun is going to be set in the western sky. And if you are facing south, the western sky is to your right hand side. And then we see all these constellations. See the moon over there? They all rise in the eastern sky, and they all set in the western sky right there. See, the moon is gonna be set. Now the moon went down, the sun is gonna go down, and then the stars will go down. So all of this motion is caused by Earth rotation on its axis. And we call this type of motion daily or diurnal motion. Okay. Go back to our in fact, let me show you one thing here quickly. Let me go back here and there. Now, the sun is always located on a line we call the ecliptic line, which is here represented by the green line. See that? It's a green line. And I will also try let me see if I can find it in an easy way. Just a second. This is the ecliptic. And I will just get rid of daylight, right? And then the sun is seen against a constellation here, the region Leo. This is Leo, looks like Leo. It's right there. And so let me bring this Leo. Let's go. So Leo in there. Let me bring label 2. There. Okay. Now, and I would change and pretend that I'm getting out of Earth. I'm not connected to Earth anymore. And I will be staring at this celestial region all the time. And one day will pass. And what I notice is that as the day goes by, oh, that's the eclipse. Cool, huh? See that? Solar eclipse. As the day goes by, the sun is slowly seeing drift from west to east in respect of the stars. Again, why do we see that? It's because Earth is the one orbiting the sun, which leads to the second major motion we should be able to observe on a time scale of a few days or so, and that is Earth revolution around the sun. So if I let this go a little bit faster, we keep staring at the same star region. Earth is not part of the rotation anymore. Pretend you are out of Earth looking out to the celestial sphere or looking out to the stars. We see the sun kind of migrating from west to east in what we call direct type of motion. So let me get rid of this and go back to the slides. And again, if this is not clear right now, I will explain again when we have the chat room. But basically, the ecliptic line in green, as you see over here, is the line defined by the sun's apparently path in the sky. And this apparent path is caused by what? By Earth itself orbiting the sun. And there you go. So this picture gives a better representation of what exactly goes on. As we look from north down on the solar system, we see Earth counterclockwise going around the sun, and which means from Earth we don't perceive, we don't have the sense of Earth really moving, but from Earth, if we look at the sun every day on a consistent time, Earth is moving counterclockwise. We would see the sun visiting these different constellations called constellations of the zodiac on a time scale of weeks or so. In fact, we should never look directly at the sun, but we can track the sun position without looking directly to the sun. How do we do that? Well, we wait for midnight and look up to the sky and see which constellation is crossing our meridian. And then we would know which constellation the sun would be projected if observed at noontime. So, because of this apparent motion of the sun in the sky, as a result of our revolution around the sun, we experience seasons. And the seasons are always in reverse. So, as when we have fall going on in the northern hemisphere, as now, the southern hemisphere experiences springtime, and when we have summer up here, the southern hemisphere experiences winter. So December 21st is, or 25th, is a lot of festivities in the northern hemisphere, most of them with some thematics of cold, right? Christmas tree and the snow and all of that. And then you go to the southern hemisphere, I'm Brazilian, since we imported all these traditions from the northern hemisphere, although in Brazil is a heck of a summer day, pretty hot, and you see all these people in the streets dressed like Santa Claus with a big beard and hat, and it's just amazing. And it's summer, right? So the seasons are in opposition if you go from southern to northern hemisphere. So why is that? Why seasons? Well, season is caused not by the proximity of Earth to the sun. It has nothing to do with that. So when it's summertime, Earth should be closer to the sun. This is a myth. This is not correct. So the seasons are caused by Earth having a tilt of its axis of rotation with respect to its orbital plane. And when Earth is tilted towards the sun in the northern hemisphere experiences summertime. And when 6 months later, now that tilt is pointed away from the sun, we experience winter time, whereas southern hemisphere now tilts towards the sun. Southern hemisphere experience summertime. So I'm gonna browse through, so you can see probably better here in this display. In summer solstice in the lower left hand side, in the summer solstice you see the northern hemisphere is nicely exposed to the sun, whereas 6 months later, if you look at the winter solstice in the northern hemisphere, the North Pole, in fact, is not receiving sunlight, and United States and all these northern countries receive less amount of hours per day where the sun is visible, first of all. And second, the sun is lower in the horizon. And again, I will simulate that in the planetarium software when we have the chat room. So moon. The moon has a synchronous rotation, which means it rotates around its axis the same amount of time that it orbits Earth, and that is 27.3 days. So it's called synchronous because the time is basically the same. It gives one rotation and one revolution at the same time, and this is caused by gravitational tight between those two bodies. They are too close, and gravity does these tricks. It's not an uncommon factor in objects in our universe. Some of them have the same feature. That's called synchronous rotation, which means the face of the moon that is, or the hemisphere that is facing Earth, is always the same. We do not see the moon's far side because the far side is always far side. The hemisphere that faces Earth has always the same features. It's always on view, like if you are playing dance, holding hands of somebody, both of you are going around each other, so you always see the face of your partner the same. You don't see the back of his or her face because him or her is not spinning in front of you. You have hold hands, you are facing each other, and you both revolves around one another, right? So you always see his or her nose, if I can put that way. Now the moon goes through phase because as moon orbit Earth, it receives. No matter in which position of the moon orbit is, it's always half lit by the sun. So no matter if the moon is in the full phase or new phase or first or last quarter, it's always half lit by the sun. So if you are out in the space looking down the moon, you're going to see the moon half lit as well as Earth. Now, sometimes we see all of that half lit hemisphere, and we call that full moon. That's when the half lit hemisphere is totally facing Earth. That's the case in the figure. If you look at the full moon, the sun is to the left, the full moon is to the right of Earth, and the entirely lit hemisphere now faces Earth. And you see that full moon rising at 6 p.m. and setting at 6 a.m. more or less. And all the other phases, we see some percentage of that half lit hemisphere. In the new moon, we see none of it, right? The far lit hemisphere faces the sun, and the far side, not far side, and the dark side faces Earth, right? So we don't see the moon in the new phase. Now, the phases that happen to be lying between Earth and the sun are called crescent phases, and the phases that lie between Earth and the full moon are called gibbous phase. And again, in the chat room, I will be a little bit more explicit on those details, and I will teach you a few tricks that you can learn how to determine at what time of the day certain phases are supposed to rise and set, which is going to be questions, part of your questions in your exam. So you have to know these things kind of well. You can't memorize this. You should be able to derive information on your own. And the last thing I would like to mention is eclipse. So eclipse happen because apparently in the sky, the moon and the sun have the same apparently angular size, half degree. So when the moon happened to be between Earth and the sun, we experience the solar eclipse when the moon is immersed in Earth's shadow. The shadow Earth casts in space, we call that lunar eclipse. And this eclipse happened because of specific phases. For instance, in lunar eclipse, we are observing the moon in the sky. The moon is in a full phase, and then it start entering the shadow, and then we see the moon kind of in a copper coloration because it's completely immersed in Earth umbra. This is in scale showing the solar eclipse, and you see that the umbra moon cast on Earth is just a tiny region. And that's what in 5 days from now, I will be able to see it as I travel up to Oregon. And in solar eclipse, we can see some of the sun's atmosphere as like corona and all of that, which usually we don't. So those are the aspects of chapter 2. They're important. One, there are two major motions going on: Earth rotation on its axis and Earth revolution around the sun. And because of these two motions, we observe most of the changes in the night sky during our lifetime. There are a third motion called precession, which is caused by the combined pull of Earth and the Sun on Earth. Earth has a bulged equator, and because of this combined gravitational pull, Earth wobbles in space on a time scale of 26,000 years. And because of that, we experience the so-called precession. And I will show that in the planetarium in our chat room. The second aspect is the definition of celestial sphere as being something imaginary. It's not real. Stars are not fixed in anything in the space. Stars are free to go, but we still use the notion of celestial sphere and divide the sky in regions we call constellations. Constellations are regions. Constellations in modern astronomy is not a group of stars in the sky, it's a region. In that region, it happened to have stars and planets and probably supernovae and all that kind of stuff. The moon goes through phases. The moon orbits Earth in 27.3 days, the same time it takes to complete one rotation around its own axis. It's called synchronous type of motion, and it goes through a system of phases as a result of its revolution around Earth. So the moon is always at all time 50% lit by the sun, but sometimes we see all that lit hemisphere, and we call that a full phase. Sometimes we see only half of that, we call quarter phases, and sometimes we see nothing of it, and we call that new phase. When we experience solar eclipse, the moon is in a new phase. When we experience lunar eclipse, the moon is in the full phase, and eclipses don't happen every single month because the moon's orbit has a small inclination, about 5 degrees, with respect to Earth orbit around the sun. So the moon is not always blocking the sun, or not always inside Earth umbra. Okay, all right.